Mrs. Kingsbury here again. Today's lesson is focusing on what I call target number 4 for this unit. You're going to be able to identify when a system of equations has one solution, or no solutions, or infinitely many solutions. So there's 3 different types of solutions that are actually possible when we're working on systems. So the first one is similar to what we have been practicing. All last week, target number 3 was that you could solve a system graphically. And this is what happens when the 2 lines obviously cross each other at that one point of intersection. And the reason they cross each other is because the equations have different slopes. The slope is obviously going uphill, so it's puff, puff, positive. The slope is obviously downhill, so it's nice, negative. And what that means is they will always cross each other at one location. If you think about it, because we're using straight lines, you're never going to get more than one solution. They can't cross each other twice if they're both straight lines. Now, this scenario is something we did talk about a little bit last week, but this week you really have to make sure you understand it. When this line and this line get graphed and they end up being parallel to each other, think about train tracks. Train tracks are parallel because they're the same distance apart. They're never going to come together across. They're never going to go apart. We say that this system actually has no solution. They will never cross each other. We do not have a POI. And what that means when you look at the equations is you had to have the same slope. They have to have the same steepness. Both of these lines are going up in the same direction as the other one. But what's different about these lines, you see this one has a y-intercept down here, this one has a y-intercept up here, so that means we have different y-intercepts. So what we're doing at the top of the sheet here is we're just kind of going over the 3 types that you're going to expect. But down here, it's really important that you understand the reason we have a solution is because the slopes are different. The reason we have no solution is because they had the same slope but different y-intercepts. So these are the characteristics that we look for to determine what kind of solution we have. And that's very helpful, especially if we don't want to take the time to do our graphs every single time like we have been practicing. All right, so third scenario. This is when we graph a line, and then let's say we have another line. You might remember having to solve for y equals. Let's say this line is y equals 1/2 x. Let's pretend that's minus 2. Let's say that's the equation of this line. And then somebody else says, you know what, I want you to graph this line, 2y equals x minus 4. If you see what I did there, I just doubled all of my terms in the original equation. So it looks a lot different, but it's actually the exact same equation. I can solve for y equals. I can get my y equals 1/2 x minus 2, and of course it ends up being the same exact line. So it's like plotting that line on top of itself. So we have every single point lining up, and this is called infinitely many solutions. The points line up forever and ever. It goes forever and ever. This is when you have the same slope and the same y-intercept because you end up having the same exact equation after all. All right. So I mentioned before that these characteristics are very important to understand how they go along with the type of solution that we've looked at. And the reason being is I don't want to always take time to do the actual graph. Graphing is important. I'm still going to have you practice that this week, but it's almost more important on here if you look at the slopes and the y-intercepts of these equations, and then you can identify the type. We don't have to get graph paper out. We don't have to actually count boxes and all that good stuff. All right, so number 1. In this equation, we have a slope that's 1. In this equation, we have a slope that is -1. So hopefully right away you notice that, hey, I've got one line that's going to be going uphill. I've got one line that's going to be going downhill. They have to cross each other, and that means this scenario has one solution. All right, next one, very similar. We have a slope that's 4. Don't be confused, even though I changed the equation a little bit. This is your slope of 6. Now, even though they're both positive, that means the 4 slope is going to be going uphill. The 6 slope is going to be going uphill. But the thing is, even though they're both positive, they will cross each other. The 6 slope is a little steeper than the 4 slope, and they will eventually cross each other. So this is another example of one solution. And again, it's because when you looked at the slopes, they're different. And that means the lines have to cross each other. All right, number 3. Looking at this one, we have a slope that's negative 11. And the other equation, we have a slope that's negative 11. So that means we fit into one of these two categories. We know that the lines are the same steepness, they're the same rise over run. Okay, so we might have this scenario, but we also might have this scenario because both of these scenarios say we have the same slope. What we need to look at now is the y-intercept. The y-intercept on the first line was a positive 9. The y-intercept on the second line is a negative 11. So what that means is it fits this scenario. Both lines will be parallel, but one crosses the y-axis down here at negative 11. One crosses the y-axis way up here at positive 9. So you're going to grab the title of no solution for number 3. All right, you'll notice on your note sheet that I left some room for the next couple of questions. The reason being is if you look at this first equation, it is not already solved for y equals like the other ones that we've talked about so far. So what that means is you'll have to do a little bit of algebra to transform the equation and get it to say y equals. Remember to not combine your x term with your constant term. So now that we have our equation in y equals form, we will see that it's the exact same equation as the other one given. So this system has the same slope. This system also has the same y-intercept. So finally, we get an example of a system with infinitely many solutions. If I can spell infinitely correct. There we go. So remember, this one's same. We look for the same slope, the same y-intercept. And we know it's infinitely many. It's basically just graphing a line on top of itself, and every single point is going to line up. So that's why it's infinitely many POIs. All right, question 5. You also notice that one equation says y equals. This equation does not, so we're going to do a little work. We're going to move that x term out of there. We're going to bring this over. Be careful, that's a negative. And once again, we see the exact same slope. We see the exact same y-intercept. So you got it. It is infinitely many solutions. Again, we have the same slope and the same y-intercept. Now, why don't you go ahead and hit pause. You should try question 6, question 7, question 8. There's definitely some solving to do on each one. And I would like you to see if you can fit it into the correct category that we talked about on these different types of solutions. When you're done trying those last 3 for yourself, go ahead and click play, and then you can check your answers. Okay, I switched over to use a green pen, so I hope you can see it okay. This equation already said y equals, so I can see where the slope and the y-intercept is when I need it, but this one needed us to work on it and solve for y equals. So hopefully you remembered to transform this by moving that 6x term, bring down the negative 6x with the constant 24, and then because your 6y term, we want to get rid of this coefficient of 6. Hopefully you remember to divide all your terms by 6. This cancels. It gives us this y equals. Negative 6 divided by 6 gives us a negative 1. So we could have written in our invisible negative 1 here. And at the very end, it turns out we have our y-intercept of 4. So if you remember what we talked about with the different types, we have a slope that is different from the slope right here. That immediately takes us to this category that one of these lines is definitely going to cross the other one and give us one solution. Remember, what we're worried about on this lesson is just identifying what type of solution. We don't actually have to find the POI right now. We're just trying to see which category it fits into because there are different types of solutions. All right, so number 7, I thought this one was a little bit easier because this equation already had the value set up y equals. This one needed a little work, so as you can see, subtract 9x from both sides. And then if you're careful, excuse me, you're going to notice that we did have the same slope of negative 9x, and it almost looks like we have the same y-intercept, but there's a slight difference. This y-intercept is up at positive 3. This y-intercept is down at negative 3. So the category that tells us is we have the same slope, so they're going to end up being parallel, and they have different y-intercepts because, again, one is down here, one is up here. They are never going to cross each other. Remember, it's just like train tracks. So this one fits into the category of no solution. All right, and that brings us to number 8. If you struggled a little solving these for y equals, that's okay. We're going to do lots more practice before we move on. All right, so the first equation definitely needs to be solved. So hopefully you subtracted your 5x. Bring down, divide by the coefficient of 2. When you divide this by 2, it does not come out nice. Remember, if you have a decimal, it's best to change it back into a fraction. So as you can see, I just left it as a negative 5 halves x. The constant term can be divided. 4 divided by 2 is 2. So this is the equation that if we had graph paper and we wanted to actually go ahead and find the POI, this is what we would graph. Now the other equation also took a lot of work. We had to subtract our 20x. We had to divide by our 8. Right here is where you need to be careful and you need to reduce that fraction. Both the numerator and the denominator can be divided by, I believe, 4. So if you divide by 4, that's where you're getting the negative 5. And if you divide by 4 on the bottom, that's where you're getting your 2. So it turns out we have exactly the same slope that we would be graphing if we had graph paper. And we have exactly the same y-intercepts. So last example is exactly what we talked about right here. The same slope and the same y-intercept leads you to graph the first line directly on top of the second line. Every single point lines up, and that is why this is the category of infinitely many solutions. Okay, so that wraps up our notes on this topic. As always, if you have any questions or concerns, email me. I'll get back to you pretty quick. And there is practice assignments to go along with this topic. So give them a try and let's see how we do.